In order to better understand regression analysis, sometimes it's really useful to calculate the regression coefficients by hand using a numerical example. And then you get really a feel for how the coefficients are actually calculated, where they come from, and how they might change if you changed one of the data points that you have in a data set. So remember what we're trying to do. We're estimating an equation, yi equals alpha hat plus beta hat xi. We're estimating the parameters alpha hat and beta hat from data that we have, from observations that we have, x's and y's. So we have pairs of xi, yi for a sample of data. The x is the explanatory variable, the y is the outcome variable, and the beta hat is how much x affects y. So it tells us how much a 1 unit change in the x variable leads to, if we're interpreting it as a causal framework, how much a 1 unit change in x leads to change in y. So that would be the slope, the parameter beta hat. Now you know from your textbook that there's a formula for calculating beta hat based on the data, and if you're using Stock and Watson, that formula is there on page 115 of Stock and Watson, and the formula says take the summation of xi minus x bar multiplied by yi minus y bar, so the summation of all those terms, and divide by the summation of xi minus x bar squared. So that's the formula we have. And we're going to go through some numbers to see how we'd actually calculate that, what those summation operators are actually doing and what they're looking like. And then for alpha hat, we have alpha hat equals y bar, that is the mean of y, minus beta hat that we've just calculated up here, and times x bar, the mean of y. So we need to calculate the mean of x, the mean of y, the summation of xi minus x bar times yi minus y bar, and we need to calculate the summation of xi minus x bar squared. So let's go ahead and do that with some numbers. So here's our data that we have. So we have observations on x. We have 6 observations. So there's 6 observations. And each observation is a pair, so x1, y1 is this, x2, y2 is this, x3, y3 is this. And if we graph them, we'll see in a second, we can graph them in the Cartesian coordinate system. Each one of these pairs is a point in the Cartesian coordinate system. So we start doing calculations, because we're going to calculate the regression coefficient. We add up all the x's, and we get the summation of x is 27, divide that by 6, we have 27 over 6. We add up all the y's, and divide by 6, we get the mean of y. We add up the xi minus the mean of x, and take the square of that. So what does that look like? Well, the first observation of x is 2, so 2 minus the mean of x, which is 27 over 6, squared. Then we have 3 times minus 27 over 6 squared, then 4 minus 27 over 6 squared, then 5 minus 27 over 6 squared, 6 minus 27 over 6 squared, and 7 minus 27 over 6 squared. So it's xi minus x bar squared summed over each one of the values of each one of the observations, each one of the x's. Well, if you do that calculation, you get something like, you can use your calculator, or easier to plug it into Excel, you'll get approximately 17.5. I've done a little rounding there. Let's go on to our next term. Oh my goodness, look at this mess. Xi minus x bar times yi minus y bar. I'm going to do some simplification first, because it'll be easier to do the calculation if we do some simplification. So I'm actually going to multiply this term out. So I'm going to multiply the xi times the yi, the xi times the y bar, then the x bar times the xi, then the x bar times the y bar. So I get xi times yi, x bar times yi, xi times y bar, and x bar times y bar. And we have the summation sign, we have the summation sign here. So we need to carry that summation sign across each one of these four terms, which we've done here. Now, the sum of xi over y, I'm going to leave that for now. With the rules of summations, I can take the x bar out of the summation sign. So notice here, the x bar is now outside the summation sign because it's a constant, it's just a number. So we take it out of the summation sign, so we have x bar times the summation of yi. Then we have y bar times the summation of xi, and then the summation of x bar y bar is just n times x bar y bar, because x bar and y bar are constants. So in some sense we have x bar y bar summation of 1 from I equals 1 to n. So that's just 1 n times, and that's n. So that's why we can multiply it by n here. So do some further simplification. A little trick is take these terms and multiply by n and divide by n. So it stays exactly the same. We do that to this one, multiply by n, divide by n. Notice that now we have y bar over n and summation of yi over n and summation of xi over n. That's just y bar and x bar. So now I get this here, and you should follow these steps, make sure you understand them. So now the one of the n times x bar y bar and the sum, the positive n bar times n times x bar y bar, those two cancel out, so I'm left with this expression. And this is much easier to calculate because I already know what x bar and y bar are. And so now I add up x times y. So if I go back to my table, x times y is 2 times 7 is 14, 3 times 2 is 6, 4 times 8 is 32, 5 times 14 is 70, and so on. So I have all those terms here, and then I add them all up, I get 264. Then I have this this term here that I'm subtracting, and I'm going to end up with approximately 25.5. So now I've calculated the numerator and denominator in my expression for beta hat, so I get 25.5 over 17.5, which is approximately 1.46. And then I plug in the numbers for alpha hat, and I get approximately 2.3. So what does this look like then? Well, here's the Cartesian scatter plot of my points, right? So I have 2, 7 here, then I have 3, 2 down here, then I have 4, 2 here. So my equation is y equals, let's go back and check, 2.3 plus 1.46x. So if x is equal to 0, y is equal to 2.3, so my first point on the line is right here. If x is equal to 1, y is equal to 3.76, so 3.76 is about here. So those are 2 points that are on my regression line. This is my regression line that I've estimated. So I connect those 2 points, and I get a line that looks like this, and this is the line that represents this equation. So that's my regression line that I've just calculated. I calculated the slope and the intercept for the regression line using the data that we have. For an exercise, maybe you want to try to calculate the r-square for this regression. That is the explained sum of squares over the total sum of squares. So right now you might want to pause the video, go back and look in your text for those calculations, and the answer to the r-square is going to magically appear after you've done your calculations and you resume the video. Can't wait, huh? So it is approximately 0.42. Is that what you got? I certainly hope so. See you next time.